start recording. Okay, so symmetric IRB, right? This is nothing but VXLAN direct routing, right? So, and many times you can combine asymmetric and symmetric IRB together, right? So that is also possible. So let's first understand what is symmetric IRB. Okay, so okay, so first of all, do you guys know what is VXLAN direct routing? Say these are two VTAPs, right? What is VXLAN direct routing? Anyone has idea?
The routing happens on the same VTAP.
Okay, so routing happens on the same VTAP, right? Okay, yeah, that is one. So basically, we in direct routing, do we have SVI, all the SVI on all the VTAPs? So as in indirect routing, right? We need to have all the SVI on all the VTAPs, right? So what about direct routing? Okay, so basically, yeah, go ahead.
Yeah, I think you don't need to have the SVIs on every VTAP, but you need to have like a common SVI between VTAPs to do the routing between VLANs.
Correct.
So for example, here you have like VLAN 11 and VLAN 12. So you need like a common VLAN, let's just say VLAN 15 to route between subnet in VLAN 11 and subnet in VLAN 12 for the host to talk. Yeah.
Right. Yeah. Yeah. So basically, as Kamil mentioned, we don't need to have SVI on all the VTAPs, right? So let's consider this. But yeah, before we go on to the VXLAN, right? Let's discuss about normal without VXLAN, right? So let's say you have host H1. This is the IP address of H1 11.10 VLAN 11, and gateway is here. Okay. And host H2 SVI is here. Okay, so there is no SVI for 12 VLAN 12 here, and same no SVI for VLAN 11 here, and this is host H4 which has 12 sub IP address in 12 VLAN 12 subnet. Now we want to communicate between H1 to H2, right? H4. It's a normal switch. Okay, normal switch. There is no VXLAN. Basically, it's a normal. How can we communicate between this two, H1 to H4? Are you guys getting my point? Question?
Yeah. So we can create like another segment in between VTAP 1 and VTAP 2. Let's just say, like, I see you've got like a route to get to subnet 11 for VLAN 11, pointing through 15.15.1, and then the same for VLAN 12, but pointing to the other VTAP. So we can just configure, an SVI with VLAN 15. This one will be .1, and the other one will be on VTAP 2 we'll have .2, and then we just allow that VLAN 15 between VTAP 1 and VTAP 2. But like you said, there's no VXLAN. It's just
it's a normal layer 3 switch.
Yeah, at this point, yeah.
Yeah. So basically, what we can do is, right, as Kamil mentioned, we can have VLAN 15, right, on both the switches, right? VLAN 15 SVI, which is common on both the switches, and we can assign IP address 15.15.1 at one side and 2 at other side. And what we can do is we can configure route. So on VTAP 1, we can route that, hey, if you want to send traffic to subnet 12, you send traffic to next hop 15.15.15 to this guy, right? So any traffic H1 wants to send to this subnet 12.12.12.0/24, send traffic to this next hop 15.15.15.2. And similarly, when H4 wants to send traffic to any host in subnet 11.11.11.0/24 send traffic to this interface, right? Next of 15.15.15.1, right? So that way we can make this H1 and H4 communicate with each other, right? Without having all the SVI 12 here and SVI 11 here, correct? Is it clear? Any question on this? Okay. So now let's come to the VXLAN, right? So this is what we discuss is normal routing, correct? But what about VXLAN? Let's say we have VXLAN. What should we do, right? So VXLAN, consider same situation, right? You have SVI VLAN 11 here and SVI VLAN 12 here, and you want to communicate between these two. Okay. What should we do? Right. So one thing what we can do is we can create one common VRF between these two. Let's say customer A VRF, right? Or A VRF. Let's say VRF A. Okay. Between these two. So basically how we configure this under VXLAN, right? So if we go to interface VXLAN 1, right? Interface VXLAN 1, right? We configure that VRF A, and we assign VNI to that VRF. VNI 2000. Okay. So this is our configuration that VRF A VNI is 2000. Okay. So basically what we do. So now as soon as we configure this, right? As soon as we configure this under interface VXLAN 1, it will, because we have VNI, right? And generally VNI is mapped to what? VNI is mapped to what? Generally, what is the mapping between what? VLAN and VNI, right?
Yes.
Right? VLAN to VNI. Correct? So we have this VNI here, right? For this VRF A. So what it will do as soon as you configure this, this will create dynamic VLAN automatically. Dynamic VLAN. Okay. Basically VLAN, it will create dynamically any VLAN, right? And so let's say it creates dynamic VLAN 20. Okay. In this case. So it will create dynamic VLAN 20 and that is mapped to VNI 2000. So this is internally, software or basically our implementation will do this. So basically what is our mapping here is that we have VRF A, which is dynamic VLAN 20 and VNI 2000, right? So this is our new VRF, right? Or you can say that there is a one VLAN, right? Dynamic VLAN, which is present on both the devices, right? And through this VRF or VLAN or VNI, you can communicate between these two devices. Is it clear? Any question? Are you getting this?
I have one question, but it's not really, it's sort of related to this concept. The dynamic VLAN that we assign, like VLAN 20 in this case, which before in the previous example was VLAN 15, which is like the common VLAN to be able to route between VLAN 11 and 12.
Yes.
The dynamic VLAN 20 is if VXLAN picks VLAN 20, for example, can we create like VLAN 20 instead of VLAN 11, or has to be unique?
Oh yeah, it has to be unique. So as a for example, I have taken this VLAN 20, but if we check, it will generally take, some other VLAN.
Something that's not in use, probably.
Yes. So see if you see 1197, right? So generally it will be like this. So this is dynamic VLAN it has created. Okay. So basically, it will take configure VLAN which is not in use, right? And also it will be like not in this range. It will be some different range, more than
Okay.
1000 or 1100 something. Okay.
Mhm.
So yeah,
Thanks.
this is what, so if you run show interface VX, then so let me show you the config, right? VXLAN 1, right? So this is my configuration, right? So VXLAN VRF A, right? In our case, or VRF A, and I have configured VNI 10, right? So VRF A, VNI 10. I also have this two other VLAN to VNI mapping, okay? But this is the one that VRF A and VNI 10. And as soon as we configure this, it generates this, that dynamic VLAN 1197 that is generated dynamically, and that will be mapped to VNI 10. Okay. And this is also the VRF to VNI mapping. So you will be able to see that VRF A, and this is the VNI associated with it. And this is dynamic VLAN created and associated with this VNI. Okay. So this is how it will reflect in show interface VXLAN 1 table. Okay. Okay. Any question? Any other question? Okay. So basically what you are doing is you are creating dynamic VLAN 20, right? On this. And now how packet will flow, right? So let's say H1 wants to communicate to H4, right? So what will happen? Okay. So now you are, so this is VRF A, right? So this is VRF A. This is VRF A. So what you have to do is this in SVI, right? SVI 11 or SVI 12 also should be part of VRF A, right? It should be part of VRF A. Okay. So let me, right? So here this SVI 110 is part of this VRF A, correct? Similarly, here also we should have part of VRF A, and same here. Okay. So basically all these VLANs are part of VRF A, then only they can communicate, right? So what will happen? Your packet, when it lands on this VTAP, it will be part of VRF A come, right? So this is, let's say, VRF A. From there, it will check the route for 12.12.12.0/24 subnet. Okay. So basically through EVPN, we populate this thing, populate this, okay, this route information. So what is that? That to send packet to 12.12.12.0/24, that is this site subnet, send packet to VTAP2, that is this VTAP, basically IP address of this VTAP, VNI 2000, right? Packet encapsulate, basically it's VNI 2000, and MAC of this VTAP, right? MAC of this VTAP. So this is what the route we will generate. So based on that route, what we will do is we will encapsulate the, basically send that packet over this VRF or over this VLAN, which is common towards this site. So basically we will route the packet from VLAN 11 to 20, right? 11 to 20, which is common VLAN. From that, or this VRF into this VRF, and then we will forward this packet to this VTAP. Again, because it has end host is in VLAN 12, so we will again, route the packet from that VRF A to this VLAN 12, and send it across. Okay. So basically, because you don't have common VLAN 11 and 12 only on this VTAP, there is no common point, right? So we will create one VRF, assign it VNI, and as soon as we assign VNI, it will also create dynamic VLAN, and that dynamic VLAN will be present on both sides. So that will act as a common path for us to forward the traffic, okay, between one VLAN to another VLAN. Is it clear? Any question? Feel free to ask, because it's
yeah.
complicated.
So this verse, right? Verse to VNI mapping, there is a dynamic VLAN generated on VTAP1 and VTAP2.
Right.
But how does this VTAP1 and VTAP2 like get to know like this dynamic VLAN as the same?
Yes. So let's see here, right? Okay, so that's a good point that, so show interface VXLAN 1, right? So it's a 4497 and this is 2A. Show interface VXLAN 1. Okay, so I think as soon as we generate this, we send out this. Okay. Basically, one point is that you need not have to have this VLAN same across two devices. The reason is when you forward any packet, right, from one leaf to another leaf, it's what you are going to send is VNI information. So here it's 1197 and here it's 1198. That does not matter, it's local, right? When you send the VNI 10, here you will map it to 1198 VLAN, right? But that's fine because here locally VNI 10 is mapped to this another different VLAN 1198, right? So that's the reason that you need not have to have same VLAN mapped to this VNI. Obviously your VNI should be same. So your configuration